manipulate through the individual objects. So like how will you manipulate through the file objects in your Unix file system? You can do mostly those functionalities for your project objects. So the add object commands manipulates objects and directories in the technical repository and control permission to access objects. When you want to view a particular DML file which is present in your sandbox, you issue a cat command, or you can use a VA editor to view the file. If you want to view the contents of the DML which is present in the repository, you have to use add cat command. So add object cat and then the file name. So add object, you can use the add cat. Okay. And if you want to change the permissions, AME is also called technical repository. And the other command to change the permissions for a repository object, chmod. That's the Unix command to change the permissions. The same command, chmod. So use the same command to change the permissions. If you want to copy an object, add object cp. If you want to display the long listing, add object ls. Pretty much same to the Unix counterparts. And if you want to create a directory in your project structure, in your EME, so you will use add object mkdir to create a directory. Okay. You want to rename an object, add object move. If you want to remove a particular object, add object rm. And there is a catch in this particular thing, like since repository is having multiple versions of a particular object, your add object rm. This is actually an interview question, like what's the difference between add object rm? We have to use. Okay, wonderful. Yeah. And add object rm, add host object and then object name will remove all the versions of the repository. Okay. And so add object versions, object name, or add versions of so add object versions will give you a listing like this: version number, date, the user who checked in, and the tag and the comment. If the tags and comment are available, it will show, otherwise it will be blank. So the shortcut for this is add versions and then the object name. Hidden, we have ls-l option. I have used it. So L actually give you the permissions, size, and then those things, right? If you just issue an ls alone, it will not give you the long listing format. So L is used to give the long listing format. And then we have add project commands. So it's a broad set. So under this add project commands, I've just listed the commands which the developers use. So add project commands actually it is used to entail. So you can use to create a project, delete a project, templates, project parameters, and we can perform checkout and check-in. So normally you'll be given access to checkout and check-in for your own projects which you're working on, and for the other things, like you will not be able to execute, for example, like add project create. So it's used to create a project in the repository. So those things only the administrator will be given. Have a GD access, you can do it from the backend using the add project export. So it is used to check out a sandbox from the repository. So updates a sandbox from the technical repository, checkout, and the command syntax is add project export, the project path, and then hyphen base dir sandbox path, and the check-in you have to use add project import. There you can check like whether this particular command is working correctly or not. Just a dry run for this command, and this hyphen dry run option is present for most of the commands. Okay. You can check the parameters in the help file. And one more command is add project show command. So when you want to check the available common projects for a particular project, you can use add project show command. So to list you all the common projects, mean the public projects. So here the important command which developers will be using is add sandbox run. So it is used to run a particular graph or a plan file or a pset file. The object path.
And like this is in the graph. Okay, it generates .bat in Windows environment.
And then we have add repository command. So that will be run by the administrators when they are first creating a repository in your environment, environment. So it creates an empty technical repository. So after they create the repository, they start creating the projects. And so you just need to be aware of the commands that are used for managing EMS. So that's why I have listed it here.
Okay.
Where repository create one and destroy will destroy at a list. So
these must be a subset of all the commands available, right? Or air help will give me all the available commands. Or
so these commands starts with M underscore. So mostly these commands are used to work with the multi-file environment, and there are some other environment. The first one is M underscore MKFS. So this is one of the command to create a multi-file system. So normally you will not be executing this command. This must have been already created by the repository administrator. So we just need to be aware of it, like how a multiple system is created. The syntax is M underscore MKFS, your control partition URL, and then followed by the data partition URL. So naming is up to us. There is no particular naming that we need to follow. We can do any other thing. So since it is a three-way MFS system, just using the MFS3 and then MFS3 0 for first partition, 3 1 for second, and 3 2 for third partition. And you can see that the data partitions reside in different servers. So it creates a multi-file system rooted at the control URL and having data partitions in the new directories in different servers.
File needs to be present beforehand.
No. We're not talking about original control files here. Now we are trying to create a multi-file system,
right?
Such that whenever we create a multi-file, where would the control file of the multi-file be?
Okay.
So ideally you can guess it. Three directory, your control file and your data partition. Okay. And next is ls command. Suppose if you want to get the listing of the available files, you will be using m underscore ls. And m underscore ls, it is able to specify like the files, directory, multi-file, and serial files also. So m underscore ls, then the directory path. It will show you the listing of all the files available, and if it is directory, it will be shown with the first bit as D, and if it is a file, the first bit will be empty. It produces this following.
As it is in Unix, like D is for directory, hyphen is for the first one is for this one. Like specifying that it is a file. Then R is read, access, write, and execute. This is for the current user. Then the group and current user, group, and public.
Right, others. Yeah. So user, group, others. And the information is said about permissions, perfectly correct. RWX. So 4 2 1.
Yep. So that
exactly, it will not give you the entire data. If you want to see the particular data, then you have to cat the particular partition. So cat IAMFS, go to that particular directory, get one of the partition file, and then you can view it. But as a whole, you cannot see it. Right?
Right.
So for that purpose, we have the m underscore dump. So it is pretty much similar to the view data in your GD dialog to view the particular MFS file. It can list also a serial file. It prints information about data and metadata. So there are multiple options for the m underscore dump command, and the requirement is you have to specify the DML along with it, along with the file name. and the simple usage will be m_dump DML name, file name. So it will list the records one by one. Suppose if you want to restrict the output, like if you want to see from a 5th record to 9th record, it's like the example specified here, start and end.
Now, if I had created my file with embedded DML, I would have been screwed, right?
Right. So what you can do is you can just create an DML file and you can use that here.
Okay.
And everything should be in the proper absolute path. Now I haven't given the path for DML and that.
So when you say absolute path, it's not basically starting with $AI serial or $AMIFS. It will be the exact / path.
Yes, and you can also use parameters. Okay. Provided the parameter will be exported runtime in the environment. So you should be able to understand that parameter.
Okay.
The second example is the normal usage. And actually the output will be like what you see in the formatted text output. Record 1, then field name, value name, field name, value name. And then the next line record 2, field name, value name.
Okay.
Yeah. And the other option for mdump is -partition. So you can optionally view the data from particular partition alone. So prints the data in partition 3 of the multifile. Okay, we have one more interesting option for m_dump. That is -select. You can issue a filter by expression in the select parameter. So -select equal to Chennai. So it will return the records according to the filter by.
Okay. And can I specify more than one?
Yes, and all the expressions and operators support. Whatever you can do with the filter by expression, it can be done in the -select.
Okay. So even the filter by does not support built-in functions, right?
No, you can use it.
Okay.
Okay. Next, the object manipulation commands, like to copy an object, to copy a multifile, to rename a multifile, to remove a multifile. So those are the first 3 commands: m_cp, m_mv, m_rm.
Yep.
And next one is m_expand. So prints information about a file or a multi-file to standard output. So if you issue m_expand and then the control URL, you can get the listing of the data partitions. So it will list you like where are the data partitions. And in the recent version, you can view the data from the multi-file directly using m_cat command. So we have an equal counterpart for the cat command, that is m_cat, and it will list you the entire data as well. Not in the formatted text, but it will be line by line out. Like how you are seeing in a serial file.
I did not get what is m_expand. Like how is it different from cat on the multi-file system? Like
both will be same. Both will be same.
Okay.
Yeah. And m_env. So it is the environment command. It prints information about the computing environment. So you can use it to get all the values for the variables which you have listed. And there are other options also. If you specify -v, then it will print the version of the co-op and the EME if it is available. So m_env -v or -version will let you know the version that we are accessing.
And question, Karthik, like, is this multi-file system specific to Ab Initio or is it Unix provided functionality?
No, specific to Ab Initio.
Okay. I was thinking if it is Unix provided functionality and it is available in Linux or Mac OS X, then I would try it.
No, no. So
So m commands will not be available in normal Unix or Linux or Mac
right,
environment, right?
right. And last one is m_eval. We have already seen this command. It is used to execute the DML functions if you want to test any function before usage. m_eval and then the particular string expression.
Right, and we have been using this in F8, right?
Yes, right. So basically, you can execute all these commands in your executable.
Okay.
So it is just the Unix window within your GD, like you can Unix command line within your GD. You can execute any command. If you execute a cat command, it will list you the full output, but you will not be able to see it fully. Your window will run out of space. And next one is job recovery. So if you want to kill a particular job, either you can use the kill command in Unix. You can specify the process number or process number, so that will kill the particular process. Similar to that, we have m_kill command, so that we can use to kill a particular job which is running. So, and for m_kill, we have to specify the recovery file or the job name. So you'll be able to see the recovery file in your host running directory, and that recovery file will be of the form graph name.rec.
And the job name will be equal to the graph name, right?
Yes. So whatever you see in the working directory, like or in the run directory, you can give that particular option for the m_kill command. And this recovery file will be created during the execution, and once it successfully executes the graph, this recovery file will be automatically deleted by Ab Initio, so you will not be able to see it. So what is the usage of this recovery file? So Ab Initio uses this recovery file so that it will be able to restore the execution to previous checkpoint. It will be helpful during the recovery. If a recovery file is present for a graph which you are trying to execute, then you will be presented with the different recovery options. I think you might have seen it: continue where it left off, restore the job first. If and all a recovery file is present, then those options you will be getting when you are executing, that is rerunning your graph. And m_rollback, that's pretty much similar to the recovery options that we see in GD. If you want to roll back your graph, you have to issue the m_rollback and then the URL. So URL will be your recovery file name. And there is an option to delete your recovery file also. You have to use -d option, and then the file will be deleted. You must have seen three options in the recovery, right? So continue where it left off, remove only the recovery file, remove and restart. So m_rollback -d will do the third one. So rollbacks a job to last completed checkpoint or to the beginning if the job has not completed any checkpoints. If there are any checkpoint, it will be rolled back to the previous checkpoint, previous completed. Otherwise, it will be rolled back to the first. Okay. So this is the usage. I have listed some examples. m_rollback in your recovery file. We haven't specified -d option. So recovery of the job from recovery file in progress, job rollback to phase 1. That's it. So if you want to delete it, so it is giving a hint. So use -d to delete the recovery file. Okay. If you use -d, job closed, recovery file deleted. So when you are running the next time, you will not be presented with the recovery options. It will run like this is compression, and we have some compression and uncompression commands for multi-files. m_gzip will compress a file or multi-file using the Unix gzip utility. The resulting file will have a .gz suffix added. So normally you will be using this. If and all anyone asks you about how will you compress a multi-file, then this is the way. So mostly for all the Unix commands, there will be a m_ counterpart. You can guess it like object movement or and new commands which you need to keep in mind are m_ and then your m_env, m_eval. So these are the new commands from the multiple system. So rest are just the counterparts from the Unix file system.
Okay.
So zip will compress a file, unzip will uncompress a file, and then m_zcat. So what it will do is it will uncompress a file or multi-file to standard output. Actually, we'll be able to see the original output after uncompressing. Like after it removes the compressed behavior, so it will list down the data into the standard output.
And the file name I specify as the control file name.
Yes. So only there will be control file name. We will not explicitly specify that is the control file name, because on the host it will be referred as the file name. Okay. So that's all with the utility commands. Next we will be moving on to the different contact IT tools. So before that, I just want to confirm whether you are comfortable with the commands whatever we discussed. I know.
Like going through that Unix tutorial for like I have not spent much time, but probably 2 hours in total that I'm reading the commands. Now I know a little bit about Unix. I know that CP is equivalent to copy in DOS, MV is equivalent to move or rename, both of them.
Can we start this now or do you want to start it next session?
I think that we'll be able to do make it a logical end today, and we can start. Otherwise, we can do it tomorrow.
Contact IT, as I already told you, like it is a separate license. It will not be with the usual GDE and co-op. So if you want to work on the plans, you need to buy this license from the Ab Initio, and once you get this license, you will be able to see the extra commands in your GDE. Suppose if you go to the file menu now, you will be able to see file, new, and then graph alone. No subgraph will be available like this, only graph will be available. So if you have the content, then extra options like plans will be added.
Okay. I have a question before we begin contact writing.
Okay.
In co-op, is there anything left in co-op? Like, is there anything we do in co-op, or like whatever we are doing in GDE, that's it?
And AME, we do little things like the object manipulations and those kind of check-in, check-out. And even with that, we are not exclusively involved. But we do have some options to manipulate the objects in the AME. Like how do we do it for like from the backend, all the commands which you have seen. We don't do much with co-op. Right,
so they should be able to accept me as a newbie, and because instead of training somebody in their lot, if they have a trained resource and they want to get that and they are hiring me for that, I think they should be fine with it, right?
Yes. That should be good. Okay. Okay, can we proceed?
Yeah.
So contact IT, from the Ab Initio's point of view, like it's a graphical workshop for creating and managing applications in a development environment and delivering them to production complete and ready to run. So it is used to create a complete application. Okay, so let me put it this way. So we are developing graphs. We are developing multiple graphs, and we are using the scheduler to schedule the jobs of the application, right? and we are totally dependent on the scheduler to run the Ab Initio jobs.
Right.
Otherwise, we have to be executing it manually from the backend, one by one. So either we need to go through autosys or control M, or we have to use the cron tab in your Unix. That is one way. The other way is we can use our plans to group graphs. Through the Ab Initio window, we cannot specify like run this graph first, next run this one, next run that particular script. Those kind of things cannot be done with graphs alone. So for this part, we have conduct IT. So we can instruct Ab Initio to run this particular graph, next this one, next this script. So anything. So actually in conduct IT, the individual components, as we say in graphs, will be termed as tasks. And the task can be a graph task, a plan task, or a script task or program task. So as you can say, guess like a graph task will run a graph, a plan task will run a plan. I mean like running a plan within a plan. And the next one is a script task. You can run any user developed scripts inside your plan. So it will give you a complete picture of your application. Suppose you have developed graphs and scripts for your complete application from till you are loading. You can just schedule them. I should not use the word schedule, but for your understanding, I'm just using the word scheduling. So you can schedule the different. So this is one of the Ab Initio product. It is used for scheduling. So instead of specifying different graphs one by one as a job and then maintaining the job dependencies in your control M, you can schedule all your dependencies in your plan itself, and you can use a job from the control M to call that plan. So all the internal dependencies will be taken care of in your plan itself. Okay. So that's what this line means. It has to capture both application and job processing logic in flexible and robust package. So we have our application logic like what we use in our graphs, and then we have our job processing logic. So which job runs next? So both of things are included under this particular package called. Okay. Okay. Introduction to plans. So plans represent all the interrelated elements of a system and consist of a task. So a task can encapsulate graphs, scripts, and third-party programs, methods and parameters that are used to control your task. So similar to graph parameters, we can have parameters for tasks, and there are methods. So methods are nothing but your functions that are executed against your task. And then the relationship that govern them, like which one to run first and how they are related. Whether I want to run it in the next. On a new graph, you can see all your components listed according to their folders. If you open a new plan, the component organizer will be different. It will have the components which are required to create plans. So it will be graph task, plan task, program tasks. So those kind of options will be there in your component organizer. Okay. And this is just an introduction about plans. And in the plan window, you can see like I have one script task, and then one graph task, and then one program script task, program task. Okay, these are the different tasks that are available to create in your plans. So graph task will run a graph. Program task, it runs a program or script. Conditional task, it evaluates a condition and then chooses which branch to execute. And then we have plan task. It runs a plan within a plan. Suppose you have created another plan, and if you want to use this plan inside your plan, you can do that. But you cannot call a graph inside a graph. You should be aware of it. You can create a graph inside a graph.
Yeah. I asked you about that when you told it is not possible.
Yeah, yes. Okay, graph task. So if you take the graph task from your component organizer and drag it down to your work area and right click it, go to the properties, this window will appear. Either you can double click it from the organizer or you can drag and drop, and from your graph sandbox view also you can create a graph task. You will be having the component organizer view and as well as the sandbox view on your right side in your GD window. And once you open a new plan, you cannot see the components in your component organizer. You'll be seeing only the task. And if you want to create a graph task, what you can do is you can create drag a graph task from your component organizer, and you have to manually provide the location of the graph which you are trying to call. And one more easier way is you can just drag the graph from your sandbox view directly to your plan. It will automatically create a graph task with all the parameters specified. Do you get it?
Yep.
Okay. The important parameter here is graph and the value, where we have to specify the location of the graph which we want to execute. Okay, and for every graph we have the connection points similar to the ports that are available in the graph.
Right.
Okay. We have the different dynamic interactions. So let's stop it here. We can discuss it.
Not look up file. I want to run a particular graph to do something, and I want to use that in my graph, right? And more than one graph want to do the same thing. So if we have to do it, we could still do it with the run command, or like and use the script to execute that graph, right? Okay.
I'll let you know tomorrow.
Yep.
Okay. Yeah.
And like, so 2 or 3 sessions back, I don't recall, but there was something that I asked, like if you could provide me screenshot of something. I'll check my sessions and I'll get back to you. But I had requested you some screenshot for something that I could not see.
You were asking about conditional components, but we were able to upload in this version itself.
No, it was before that session. I particularly recall that I had asked you that. I'll check my sessions and get back to you what I asked for.
Okay.
Right? Okay.
Sure.
At this moment, I'm totally blank. What was it? But I did ask you something.
I remember it was conditional components.
Yeah, that was the second thing. But before that also, I had asked something, and it was something related to the new version or anything that I could not see. Maybe a script, or I don't know for now. But I'll listen back to the sessions and get back to you what it was.